final thing always, run Terraform destroy so I don't get charged for my infrastructure.
Turn a 10 piece to a 20 quick. I got money busting out the money clip.
In this video, I'm going to go over the basics of using Terraform to set up infrastructure with AWS. So let's say we have some basic infrastructure that we need to deploy in the cloud. Maybe we have an application instance that we need to horizontally scale, and then a load balancer to distribute traffic between those instances. Maybe they're set up to a database and an S3 bucket for storage, and maybe CloudWatch logs, and there's a bunch of virtual private networking that we're doing. Traditionally, we would go into the AWS console and click a whole bunch of buttons and configure a bunch of things manually just to get an infrastructure like this set up. And this can be really time consuming and prone to human error. If I'm going and clicking a whole bunch of buttons, configuring a bunch of stuff, and I'm having to repeat this process a bunch of times, there's a good chance I'll make a mistake along the way. And what happens when I need to horizontally scale up or down my infrastructure? Or what if I'm setting up an environment just for testing where I need to set up everything quickly, maybe for a couple of hours or a couple of days, and then tear it back down to avoid getting any extra charges? If we use a tool like Terraform, we define our infrastructure as code, and then we hand that code over to Terraform, and Terraform is responsible for managing our entire infrastructure. So we can easily define exactly what we want using code and then have software manage all the infrastructure for us. So let's take a look at how we can use Terraform to manage an EC2 instance in AWS. And before you can start using Terraform, there are two things you need to do. The first is actually downloading Terraform, and there's instructions on how to do this in all different systems on the Terraform website, so I'll leave a link to that in the description. And the second thing you need to do for using Terraform with AWS is make sure that you have installed and configured the AWS CLI on your machine. So like I said, we're going to use Terraform right now to set up an EC2 instance that's running a web app. So once it's set up successfully, we should actually be able to visit this web app in the web browser. And because we write code to work with Terraform, we treat a Terraform project like any other code project. So the first thing I'm going to do is actually create a new directory for my project. I'm going to call this Terraform and cd into here. And this directory is where I will keep all of my code files that I'm going to use for Terraform. And I can create a Git repo in here, and I can start tracking all changes to the source code using Git. And you just treat this like any other code project. The entry point for a Terraform app is main.tf. So I'm just going to create that file here. And now I'm going to open this up in VS Code, start writing the code for main.tf. And for this video, we're only going to have this main.tf file. But for a larger project, you would actually break this code out into more files and modules within Terraform. And these .tf files use the HashiCorp configuration language, which is a really basic language that consists mostly of arguments and blocks. So I'll kind of explain how we use it along the way, but it's a really simple way of defining our infrastructure. The first block we need in here is the Terraform block, and this is where we can set up settings for Terraform and define the plugins we're using. So in this case, we need to say that we're using AWS. And I'm just going to paste in a code block here because this is going to be what you'll need if you're using AWS. So this is saying use this version of the AWS plugin that is provided by HashiCorp, and we're going to use Terraform version 1.0 or higher. And then I need a provider block to say that we are using the AWS provider, and then I can pass in any AWS settings to this block. So I'm going to set the region to be US West 2 for this project. And this type of configuration will exist in any of your Terraform projects for AWS. You'll need to require AWS and then set up AWS as a provider. And we haven't built any infrastructure yet. We haven't defined any resources, but I want to switch over to terminal now to show you how to use the Terraform CLI. So in this directory, the first thing you'll need to do when you create a Terraform project is run Terraform init. And if you don't end up running this, Terraform actually has really good error messages, so it will tell you if you need to run this. We'll look more at that in a little bit. But running Terraform init made a new directory called .terraform and a new file called terraform.lock.hcl. We can actually see here the version of the AWS plugin that it installed. And if we list the contents of .terraform, .providers, registry, there we go. We can see that it installed the AWS plugin into this directory. So every Terraform project has its dependencies right here. And if you were going to start tracking this with Git, you would want to add the .terraform directory to your git ignore file. And actually, I might just do that right now. I'm going to look up git ignore for Terraform. And I'm going to copy this, create a new .git ignore file. Yep. add boilerplate. So like I said, this is a code project. You do want to commit it into a version control system and treat it just like any other code project. So now that we have that set up, I'm going to run another Terraform command, and this is Terraform apply. And this is the main command that you'll end up running, because this gets Terraform to apply any changes you've made to your infrastructure. So if I run this right now, I want to see what happens, and it's saying that it would add 0 things, change 0 things, and destroy 0 things because we've set up 0 things. But this is the command that once we actually have some resource blocks written, this is what we run to actually set up our infrastructure. So the first block we're going to look at is the resource block, because these are the things that we actually create. So this could be a virtual machine, an EC2 instance, it could be security group, it could be an S3 bucket. The resources are the things that we want to define here. So the first thing we're going to use is the AWS instance, which is an EC2 instance. And when we define a resource block, we specify which resource we're creating. So from the AWS plugin, we're going to create an EC2 instance, and then we just define a local name. So this is going to be for my web app, so I'm just going to call this web app. And technically now I have defined that I want an EC2 instance created. So we could try running Terraform apply again and see what happens. And Terraform, like I said, has these really nice error messages. It's telling us exactly what's going wrong here. So it is saying that we are missing an AMI argument and an instance type argument. So these arguments go in here. The instance type is the T2 micro or T3 nano or whatever. So I'm just going to go with a T2 micro with the free tier. And then the AMI is the ID of the AMI that we want to create. So this would be like, do we want an Ubuntu base image or an Amazon Linux 2 base image? So I'm going to go find that AMI ID right now in AWS. So if we go into the EC2 dashboard and we go to launch a new instance, we're not going to create anything. It's just an easy way of seeing AMI IDs. So here's Amazon Linux 2 and here's the AMI ID for that. So I can copy that one. But I actually have my own AMI that I set up using Packer in a different video, and I'll leave the link to that video in the description. But this is an AMI that has a Node app already set up on it. So once we run this with Terraform, we should actually be able to visit this in the web browser. So I'm going to copy this AMI ID and paste it in here. And now this should be enough to tell Terraform that I want a new EC2 instance created as a T2 micro using this AMI. So now let's try running Terraform apply again. And when we run Terraform apply, it validates our code and then plans out exactly what's going to happen. So if we read this at the bottom, the plan is to add one new resource, change 0, and destroy 0. So it's going to create a brand new resource for us. And if we scroll through all of these details here, we can see that it's creating the AWS instance resource, the EC2 instance. It has some of the details here. So this is the AMI that I provided, the instance type I provided, and then a whole bunch of other properties that will be known about this resource once we actually create it. And nothing's been created yet. We always have to tell Terraform if we really want to create this stuff. So we could look at this and be like, oh, actually I created the wrong thing, and hit any other value and it won't create it. But I'm going to create this instance right now because I want to see it actually get created. So I'm going to enter yes, hit enter. And now Terraform will set up a new EC2 instance in US West 2 with that AMI ID. And if we head over to the EC2 console again, we can see that here is the AMI that it is setting up, and it's just pending, but this is managed by Terraform. So with just those few lines of code, I've actually already created a new EC2 instance. So let's go back. Okay, so that's now done, and we can see the apply is complete. We've added one new resource, the EC2 instance. 0 things have been changed, and 0 things have been destroyed. And I want to now get all of the details about that EC2 instance. So if I go back to the web console, I can click on this and I can see a whole bunch of details about it, like the public IP address, private IP address, the DNS, a whole bunch of things here. But I want to be able to see this from Terraform. I don't ever want to have to log into the web console to look at this stuff. So back in terminal, if I use Terraform state, I'll be able to view the details about the current state of my infrastructure. So here are the different options I have. If I just run Terraform state list, I can see all of the different resources I've created. Right now, I just created that AWS instance.web app. So I'm going to be able to refer to this resource using this name. So AWS instance.web app, if I copy this and write Terraform show and then paste that in, oh no, I need Terraform state show. Terraform state. state show. There we go, that instance. And here are all the details about that EC2 instance. So I can now get the public IP address from this instance, and I can go and visit the web app. I can see that it was assigned the default security group and all the other details about this thing. And these values are being told to us now because they couldn't be determined until the resource was created. But some of these values we could have actually passed in when we created the resource. So if we go and just Google Terraform AWS provider, the documentation online is really good for everything that we can do with the AWS provider. So I can filter based on AWS instance. And I can see that there's a resource called AWS Instance. And on this website, there are a bunch of code examples and a lot of documentation on all the different arguments that we can pass into this resource block. So I could specify the CPU core count or any of these other properties here. So this can be handy to know, and it is worth reading through the docs. But for now, we have enough arguments for what I'm trying to do, and that was just set up that EC2 instance. And I said this was running a web application that I should be able to visit on port 8080 because it's just a Node app. So if I go back to terminal and copy that public IP address, I should be able to go into the web browser and visit this at port 8080. So that AMI that I created is just a basic Node app that shows a random cocktail every time you refresh the page. And to get this set up, like I said, I had to create the AMI using Packer, and I did that in a different video. But then to actually set up this infrastructure was just a couple lines of code. Now, if we go back to the EC2 instance in the dashboard, and I just check the security groups here, it was assigned the default security group because I didn't specify any security group when I created it in Terraform. And the default security group is allowing all traffic on all ports, all sources, which is generally not what we want. If I was doing this properly, I would specify a security group that only allowed traffic on port 8080. I would set up some private networking, a whole bunch of other things. So there are more resources that I should have here. So right now, what I want to do is actually assign a custom security group to this so I can only connect to it on port 8080. And this is going to be another resource block called AWS Security Group, I think. But I am going to go back to the online documentation here and look for that, and there is down in VPC AWS Security Group. And here is a basic example of how to create a security group. So I'm going to copy and paste this block because it's basically what I need, except I need to make a few changes here because instead of accepting traffic on port 443, I'm going to accept traffic on port 8080. So I'm going to change the name, allow on port 8080. That's actually the description, not the name. I'll just call this app security group. I'll give that a local name too. I'm not going to assign this to a custom VPC, so I can delete this and let it just be assigned to the default VPC. I actually don't want this tag. I'm also going to simplify this a little bit because I don't want to include a description and other arguments here. So if I, instead of making this equal to an array of blocks, if I just make this a block, it actually allows me a little bit more freedom here. And you can specify multiple ingress and egress blocks here. So if I wanted another rule, for example, if I wanted to accept on port 80, I could just make another block, but I'm not going to do that. I'm just going to leave it at port 8080. And then I need to specify for the AWS instance, the security group. I need to attach these. So once this is created, I need to make sure that this AWS instance uses that security group. So if I go back to my AWS instance here and I just do a quick search for security group, let's see. So there's security groups, which is for EC2 Classic, a list of security group names to associate with, or there's the newer VPC security groups ID. So this is a list of security group IDs, and this is generally what we'll use to connect a security group to the EC2 instance. So I'm going to bring this in here, just paste it in, and this is going to be a list of security group IDs. So just like I got the AMI ID right here, I need the security group ID from this security group. And I don't want to hardcode this at all. I want to tell Terraform, create this resource, and then whatever the ID of this is, just dump in here. And the way we do this with resource blocks is really easy, just using dot notation. So AWS security group dot app security group .id. And Terraform knows that this AWS instance block is dependent on this security group block. So it'll make sure to create this resource first and then put the ID of that resource into here. And the indentation and formatting's gone off a little bit here. So I will just show off another little tool here. If you run Terraform format FMT, it will actually format your code for you, so it's a little bit more readable, which is kind of nice. So it's worth doing that before you commit your code in. So I now have this security group, and I now have this AWS instance connected to the security group. So I want to apply this. I want to apply my changes. And think about what Terraform is going to do here. Should it create a brand new EC2 instance and a brand new security group and connect them and leave the old EC2 instance there? Should it delete the old instance and create a new one? Should it just modify the existing instance? Think about if I ran Terraform apply 100 times, should I get 100 new EC2 instances? So I'm going to run Terraform apply and we'll see exactly what happens. Reference to an undeclared resource. I specified port 8080, but I haven't created a custom VPC here, and I don't want to allow traffic on a VPC. I want to allow traffic from the public internet. So I'll just change that. Good error messages. Terraform apply again. Let's see. So it is going to create one new resource, and it is going to change a resource because it's going to create this brand new security group for us, but it's just going to modify the existing EC2 instance to assign that security group to it. And this is an important thing about Terraform. When we are specifying these blocks in the Terraform file, we aren't telling Terraform to create a security group or to create a new EC2 instance. We are simply planning out our infrastructure. So in our plan, we have a single EC2 instance and a single security group. So when I run apply, I want the end state of my infrastructure to reflect this plan. And Terraform knows that, and it is just going to make sure that we end up in this end state. And it might destroy things and create new things or modify things or whatever. It really doesn't matter. I don't care how Terraform does this, just as long as when apply is complete, my plan is in place, which right now is a security group that allows traffic on port 8080 and an EC2 instance hooked up to that security group that is running from this AMI. So I'm going to type in yes, and I'm going to let it make these changes. So it added the security group and it changed the EC2 instance, and we can view this in Terraform, or I'm just going to come back into my EC2 dashboard, check out my instance, and I can see that my security group should now be my custom security group that allows traffic on port 8080. I could Terraform state list just to see everything that it's actually managing for us. There's a security group, there's the app instance, and I can go Terraform state show and get all the details about this instance, and there's the public IP address. So if I want to, I can make sure this app is still working by visiting it on port 8080, and there we go. Now, if I go back to Terraform, I am just going to prove that if I run Terraform apply again, it won't make any changes. It won't do anything because, again, this is the plan for my end state, and my plan has already been applied. This is my end state. So Terraform should do absolutely nothing right now. There we go. No changes. Your infrastructure matches your configuration. One of my favorite things about Terraform, though, is Terraform destroy. Because I'm testing so much with AWS, I'm setting up things in a test environment that I need to then tear down later. I have to keep track of everything I've created. So right now it's just an EC2 instance and the security group. But in real projects, there's going to be so many EC2 instances, load balancers, databases, S3 buckets, things like that, that going through and actually tearing everything down is a huge hassle and stressful because I don't want to accidentally miss something and end up getting billed. So running Terraform destroy is similar to running Terraform apply, except instead of getting to that end state that we wanted with the plan, it undoes the plan. So it destroys everything. And again, we get this little plan here, like, okay, this is exactly what it's going to destroy. This is exactly what's going to happen. So I type in yes, hit enter, and it should now destroy everything. And if I view this in the AWS web console, I should be able to see, there we go. It's actually terminating the instance that it just created. So that's now finished destroying everything. And now there's another block I want to talk about, and that is a data block. Because a resource block is something that Terraform is managing. So if we say resource AWS instance, Terraform is going to create an instance or destroy it or modify it or whatever. It is completely in control of that resource. But a data block allows us to query data about a resource that is managed not by Terraform. So if I create an AWS instance on my own or with a different tool, and I just want to get data about it, maybe an IP address or an ID or something, then I can just query data about it using a data block, even though Terraform isn't managing that resource. But I don't want to use this for an AWS instance right now. I want to use this for an AWS AMI. I'm actually going to have to Google to make sure that's correct. Right now, I'm hard coding my AMI ID in here. And if I go back into AWS and I look at my AMIs, I can see that I actually have multiple AMIs, and that's because I create a new AMI every time there's a new version of my application. So I don't want to hard code an ID in here. I want Terraform to grab the most recent version of this app, and this is my Cocktails app, so I just want it to grab the most recent version of this AMI. So I can use a data block to query AWS to actually get the ID of the AMI that is the most recent Cocktails app. And I'm going to go back into the documentation here because I am going to have to check to see, yeah, it's an AWS AMI data source. And here is all the documentation on it, and here are all the different options I can use. And from this example, I just need these 3 arguments. So I'm going to copy these. I'm going to come over here. I'm going to call this my app AMI. I'm going to paste these in here. So I always want to get the most recent AMI because I'm always going to be creating new AMIs, and the most recent one will be the one with the most updates on it. The owner is going to be self, so because I'm creating the AMI, it is self. But we could be using like an Amazon AMI and use Amazon as the owner, but I'll leave that as self. And then name regex. So this allows me to pass in a regular expression for the name. So this is pretty easy for my requirements because I'm just going to call this cocktails-app-anything. So I'm just using a timestamp here to version it. So I'll just go like this, and then anything after that is fine. So any AMI that I own that starts with this, and the most recent version of that, that's what I want to query here. And now I can reference this data block in a similar way that I reference my resource block. So I'm going to delete this AMI ID. I'm going to say get this from data.awsami.appami.id. And now Terraform knows to query AWS to get this ID before it can create the AWS instance resource. And I destroyed that already, so I'm going to call Terraform apply. And this should set up the infrastructure exactly the same as it was before, but instead of hard coding that AMI ID, it's now being queried using a data block. And Terraform just created those 2 resources. Again, it's not managing that other resource in the data block. And if I run Terraform state show on the web app again, I should see a new public IP address, and everything should be set up correctly. I should be able to still visit this web app and see a random cocktail. There it is. That's not a cocktail. So let's look at this file one more time. We have the Terraform and provider block, which are going to kind of always be the same for creating AWS infrastructure. I have planned to have a resource that is a security group that allows traffic on port 8080. I am querying data from my AWS AMI so I can get the AMI ID. And I plan to have a resource that is an EC2 instance created from the AMI ID connected to that security group. And now this is good because it runs my application. It's a really, really small implementation. You'll generally have more resources and more blocks in here, but this is enough for this really basic application. So I am going to commit my code. And final thing always, run Terraform destroy so I don't get charged for my infrastructure.
Turn a 10-piece to a 20 quick. I got money busting out the money clip. Make a call and hit another lick. Someone get the money counter, I can keep on thumbing it. Turn a 10-piece to a 20 quick.